able to comfortably talk to me, then you'll be able to ask questions. And I want to be an approachable teacher so that you can ask questions. I can try clarifying it once, twice, 3 times, 4 times, 5 times, as many times you want me to. Okay? Now tell me, very basic question. Do you like maths or you don't? You don't.
It's fun when I understand it, but I don't understand it that much still.
You don't. Okay. If I ask you, why do you want to learn maths actually?
To get better at it.
Okay. And where you think you can do better? In which part of maths? Because maths is again a very vast, it's a very, very vast thing. Right? Yeah, go ahead, I'm listening to you. I can still go on. There's a few more topics, but algebra. This is your stronghold, or this is your area where you want to improve?
It's my medium one.
Medium one.
There's stuff I need help on, but like I know a lot of it.
Okay. So, okay. How about trigonometry, geometry?
Trigonometry, it's a medium one.
Medium one.
Pretty good.
Okay. All right. So, what is in algebra that you think you need to start with? I'm just asking some random questions just to get a feel of from where you would want me to start. Okay.
Square roots.
Square roots. Okay.
And
Okay.
logarithmic and exponential.
Okay. Exponentials. Okay. Okay. And I have a syllabus, don't worry about it. I'm just asking some random questions, not to confuse you, but to make sure that I know from where I'm going to start. Let's say, let's start with something like this, okay? If I give you this to solve, what will be the answer? This is exponents, yeah? I'm just trying to get a sense. What will be the answer for this one? Or if I say, what will be the answer for this? Okay, so these are the things that you would have certainly studied. Sometimes we tend to miss recalling it. Sometimes we miss because we have not probably practiced, or we are not in touch for some time. So that is what I do, okay? This was not to put you on the spot in front of daddy. And I'm equal to your daddy, don't worry. I'm not going to be an outsider, okay? I'm going to be like your dad. You can call me uncle or sir, whatever you feel comfortable with. Now, let's say, again, I'm just doing some basic checks. This is a rectangle, this is a square, and this one is? Trapezium? Trapezium. If you have to start with, let's look at some basic concepts. What do you mean by an area of any shape?
The amount of space
it takes, yeah? So, if you are dealing with this rectangle versus this rectangle versus this rectangle versus this big rectangle. Area means this one needs this much space to draw this needs this much space to draw it, this needs very little space. That's area. And if you talk about perimeter, what does it mean?
I think it's around it.
The boundary, yeah. So we will learn each and every aspect. I will make sure that we don't look at math as an opportunity for memorizing formulas and applying it now. I will make sure that I inject the concepts in your brain. So that I don't give a lot of assignments. I don't. I teach concepts, I give little assignment so that the kids can make sure that whatever they have learned conceptually, they are able to practice that. That will be the thing, okay? So that your schedule you stick with. I will give you enough assignment, let's say maximum for 2 hours in a week. So you can split, okay, every day 20 minutes, I'll be done with my assignment. But all the assignments that we'll do will be to make sure that the concept that we learned here in the class, that we are able to practice. Okay. Now, so you know things, okay? Do you remember what is Pythagorean theorem?
Yes. It's a squared plus b squared equals c squared.
A square plus b square equals to c square. What is a, what is b, what is c?
A is side, like side. I mean, it's one side, and then b is one side, and c is the hypotenuse.
Hypotenuse. Are we talking with respect to what type of a triangle? Right angle. Yeah. Yeah. So this is one side, this is one side, and this is the hypotenuse. That's what you're talking about? So a square plus b square equals to c square. Do you know this?
Yes.
And if I tell you how do you get to this? Do you know how to derive this? How is this formula? If I say, okay, prove the Pythagorean theorem, how will you prove it? No, I mean, again, I'm just trying to get a sense, okay, from where I'm going to start. So, in my class, nothing to be afraid of, nothing to be to feel bad about also. We are here to learn. If you knew everything, why would you come to me even? It's a half an hour drive for you, right? Yeah. So you're coming for a reason. So I'm just trying to get a sense. Okay. Now, so when I say how do you prove it? Trust me, this is the easiest of the problem to solve. This is the easiest of the concept to kind of learn. But you'll be surprised to know that 90% of the kids, even in 12th grade, don't know how to prove this. And I will explain you how to prove this. This is based on a concept called similar triangles. Okay? When you say similar triangles, meaning when you have two triangles with matching value of the angles, this angle, this angle, and this angle, what it means is that the sides are proportional to each other. Meaning if this angle and this angle are same in these two triangles, then this side by this side will be equal to, let's say this and this angle are same. So the side opposite to these two angles, let's say this is A and this is A dash, this is B and this is B dash. So then as per the property of the similar triangle, it says A by A dash will be equal to B by B dash. Okay? And we'll use the same property if you expand, you'll be able to prove this one. Okay? We'll do that in the class. Okay? Now, what I'm trying to do here is, every topic that we'll pick up, we will go through the concepts. I'll not only force you to memorize the formula, I'll try explaining you how that formula derived first. So that becomes your concept, and then we'll do some sums, and then we'll go to 𝐶 and do the exercise. Because in 𝐶, for SAT preparation, you have list of syllabus actually, and we'll pick up syllabus topic by topic, learn the concept, do some sums, and then I'll give you that as an assignment to finish that before you come to the next class. So that way, you'll be able to practice what you learned here and be confident about what you have learned is actually in line with what you're supposed to know now. Okay? So that will be the approach. So this is on geometry, we talked about algebra. How about trigonometry? How comfortable are you with trigonometry?
I don't remember it that much.
Okay. Trigonometry revolves around one thing. That is called right angle triangle. Right angle triangle, when you say, meaning one angle which is 90 degrees. And then the whole subject revolves around this. Okay? And this also extends to calculus. When you use this, so let's say if this is 90 degrees, let's say I call this as theta. Okay? So one of the formula that you would have seen, sin squared theta plus cos squared theta equal to 1. Equal to 1. Sin squared theta plus cos squared theta equals to 1. Oh, sorry. Sin squared I took you in the wrong direction. Yeah. So this is this formula is again coming from this triangle. When you learn calculus, that also will come from here. Okay. So geometry and trigonometry all are related, and we'll go through each and every topic one by one. Now let's look at some more concepts with geometry. We have not looked at geometry yet. We looked at the basic Pythagorean theorem. So let's say this is a circle, this is a square. Now, oops. What is this called and what is this called? If this is a square and this is extension of this, what is this called?
Cube.
Cube. Do you know what is the volume and surface area for cube?
Is it like side times side?
Yeah, that is the volume. So that is the formula that you would have learned. How is what we want to learn here. So that when you practice, you don't have to memorize it. You'll be able to relate it actually. That's what we'll do. Okay. All right. So let's start our class with the first topic. Let's start with the most basic thing that you will hate me for. That is called knowing about the numbers. That's the building block of math. So we are starting with the number system. Okay. What are these called? Just again, one thing you can keep in mind, I'm not going to ask you complex things. I'll stick to basics, very simple things. If I have 1, 2, 3, 4, 5, 6 and I can go on in the increasing order, what are these called? Numbers. What type of number? Natural numbers? Yeah?
Yeah.
So 1, 2, 3, 4, 5, 6, you can keep going. That is called natural numbers. If I add a 0, what it becomes? Whole number. Yeah? If I move in the negative direction, sorry. What it becomes? Integers.
Oh.
Yeah. So these are natural numbers. Add a 0, this group becomes whole number, and add negatives, it makes it integers. So integer is like a superset where you have negatives, positives and 0 all included. If you are only looking at numbers with positives, that is natural number, add a 0, it becomes whole number. Fine? This is one part of it. And I know this is something that you don't have to remember always. I mean, you don't have to keep studying always, but you will remember it. Okay, now let's look at this is called number line. Yeah. All the numbers that we looked at, natural number, whole number, integers, that can be enter number line. This is your simple number line. If you say, okay, find out 2 here. This is 2. Minus 3 here. I make one more number line perpendicular to this one. So this is where you start the graph, or you call it coordinate geometry. Yeah? Where you start looking at numbers or positions with reference to this x and y axis. This is your x axis here, this is minus x, this is y axis, this side, this is plus, and this side is minus. And both are meeting at this point, this is called origin. Yeah? So let me take a step back and see if I have confused you or I have given you some information here. So we started with numbers, different types of numbers. We tried relating that with how a number line comes into picture horizontally, and then we figured out, okay, any number can be represented on this number line. Okay. Now I am expanding that further to get into coordinate geometry. This is where I brought in this perpendicular line to this number line, and interestingly both are number lines 1, 2, 3, 4. This is -1, -2, and both are meeting at the common point, which is origin, which is the 0th point for both the lines. Okay. So this is what we will use for coordinates, graphs or anything. Now if you think about it, this is the building block of geometry. Because if you look at geometry, what is geometry? And again, excuse me if my pronunciation is the Indian way, right? You guys speak the native way, I speak the Indian way, right? So if some words I'm pronouncing it differently, just let me know if I have to correct it. Okay? So now if you look at geometry, what you start with? You start with a line segments, rays, and then you go on to make angles, then you go to triangles, then you go to quadrilaterals, then you look at circles, and then you go to three-dimensional shapes like solids. Yeah. So basically you're saying that if you're talking about geometry, you're talking about 2 points to join to make a line. That's the first part of geometry, right? And the 2 points, when you say 2 points, those 2 points are lying somewhere whom you are connecting. Let's say if you are talking about drawing a line here on the surface, you're talking about one starting point and one ending point, right? And how do you locate those points? If I have to, let's say, put a point here and a point here, how do I locate this point? I'll say, okay, this place is this far from this wall and this far from that gate. Same way here. If you're talking about 2 points, you're talking about this point is how far from this line and how far from this line. This point is how far from x-axis and how far from y-axis. So coordinate geometry and geometry are actually related. Because if you just say geometry is like a plane surface. Like a plane surface. If I put a point here and a point here, it has no meaning. It has to be with reference to some point. Right? A point here versus a point here are different. Because where they are located. It's like your address and my address. Yeah? So this point has an address. So that is where this coordinate geometry helps you make it more specific, more direct, more more relevant that way. So that is why coordinate geometry comes into the picture. Now, here, if you talk about any point, this is against the x-axis here and the y-axis in this direction. So this point, what will you do always? Draw a perpendicular line with both axes. And this tells you what is the x value, what is the y value. Meaning how tall is this in this direction, how far is in this direction, and that is what becomes your x and y coordinates. This part is clear, right? Yeah? Okay. So we'll come to this. So I'm just going one by one. I started with number line. I from 1 dimension went to 2 dimension and kind of trying to relate that. Okay, take a breath. I'm saying take a breath. I mean, feel comfortable, okay? I keep talking or I keep drinking water. If you need water, let me know. If you need water, let me know. Do you need water? No? So, this is how we will keep on relating things one after another. Now, let's go a little deeper into geometry to start with. So as I said, start with this. What is the difference between these three?
The first one is a line.
First one is a line.
This one is a number line.
I'm sorry?
A number line?
It's okay. Go ahead. Make mistakes. I want you to make mistakes.
The first one has two segments. It has a starting point and an ending point.
Uh-huh.
The second one was infinite
Mm-hmm.
on both sides.
Yes.
And the third one is infinite on one side.
Yes. You are spot on. So 80% of people, or maybe more than that, if I give this, they'll say all these are lines. But they're not. This is line. Line is something which doesn't have a starting ending point. It is just a direction. It tells you in which direction it's going. So this one is a line where you have, as you said, this is infinity length. It has no fixed length. It can go as big my board is or as big my wall is in this direction as well as this direction. It just gives you a direction, no length, no starting ending point. Okay, that's what is called line. This is called line segment. It's a baby of a line which has a fixed starting ending point. It still has a direction, but it has a fixed starting point and a fixed ending point. And you can always, in future, you can say, okay, fine, I'll put this against a coordinate geometry, against a graph to know where exactly it stands in the x and y axis. These 2 points and join them. Okay, but let's not confuse that with coordinate geometry right now. We'll only look at this is a line segment. So line segment, line. What is this guy? This is called, as you said, this has one starting point fixed and other side is infinity. It's called ray. So there are 3 variants of a line that you'll come across. So a line, both direction, infinity length, no starting ending point, just a direction, line. If you have a direction but fixed length, that is line segment. If it is starting from one place, going to infinity or infinite length in one direction, that's called ray. Something like my phone. Starting from here, starting point is fixed. Depending on how powerful my camera is, how powerful my torch is, it can go as far as you can think of. That is the example of ray. So I'll keep on giving all stupid examples to make you able to relate it with real life thing. Because if you don't, it's not fun. And most of the times we end up losing interest in things because we are not able to relate that to our day-to-day things. Do I speak very fast?
No.
Okay. Alright. So these are the three things that we've learned about light. Now let's make it bigger. So apart from one line, let's get 2 things, 2 lines. I mean, line segment and rays, people use them interchangeably and they say just a line. This is not correct. These are line segments actually, because I don't have arrows here, right? So these are actually line segments in absolute terms. But we'll keep on using line segment interchangeably. So don't worry about that. Even if I'm grammatically incorrect, it's okay. Yeah. So now we're talking about 2 line segments and the relationship among them. What is this called? Angle. Yeah. What is the difference between these 3 guys?
The first one is an acute angle.
Yeah.
That's an right angle, and then it's an obtuse.
Obtuse angle. I have a very lame way to remember it. I call it acute angle. Something that is small is always cute. So that's how I remember this. Obtuse is obviously the opposite of that, and this is right angle. And this understanding will help us know more about triangles. So far we have dealt with 1 line, 2 lines. Now let's look at 3 lines or 3 sides. That is when we end up encountering with a shape called triangles. So any shape, a closed shape. This is the first time when we are looking at a shape which is closed. Yeah. So this is called triangle. And these are all the building blocks. We have not started yet preparing for a city. So next class onwards, when your dad is not around, then is when we'll get more serious about SSC preparation. Okay. So we are just doing some preparatory things to make sure that we are able to recall some of the basic concepts that we have learned in the past. Okay. Now we are looking at a shape which can be called triangle. What is the basic property of a triangle? 3 sides and 3 angles. So you can classify triangles based on sides and angles. Now let's look at the different classifications. And we are looking at the properties because these properties will help us deal with them when we do more serious stuff with these shapes. Okay? So as I said, there are 3 sides and 3 angles. Now based on the sides and angles, you can classify them into different categories. Let's look at some of them. Let's look at the side part first. So I have, let's say, 3 triangles here. Here, okay, this is not a good drawing. My drawing skills are not that great. Okay, so first example is a triangle where this side and this side are of same length. Let's say this is 5 centimeter. So this is 5 centimeter, this is 5 centimeter. This one, let's say, is 10 centimeter, and let's say 5 centimeter. This one is, let's say, 5 centimeter, 10 centimeter, 12 centimeter. So what you can see is, this has all the 3 sides of same length. This has 2 sides of same length, one different. This is all different. Do you know what is the name of these guys?
Equilateral.
Equilateral.
Scaling.
Scaling is this one.
And then
Isosceles. Yeah. So when you have all the 3 sides of different length, that is equilateral. Equilateral. Lateral stands for side. Equi is shorter form of equal. Equilateral. Equilateral and isosceles. Isosceles is when 2 sides are isolating the third side. 2 sides are isolating the third side, saying that we are friends, you are not. Isosceles. Okay. Some what do you call creative, funny or lame way to remember this. Okay. This one is scalene. Something similar to alien. Yeah. Very, very different, very unique, very much non-comparable. That is how it is scalene. Okay. So based on sides, there are 3 types of triangles. Now, based on angle, you have again 3 types. Based on angles, if you remember, when we were looking at the angles, we looked at 3 types of angles: acute angle, obtuse angle, and right angle. That comes into play here to give the name or categorization for these triangles. Here, all the angles are less than 90 degree. Okay. Here, one of the angle is 90 degree. Here, one of the angle is greater than 90 degree. Since all the angles are less than 90 degree, so all the angles are acute, small. That is why it is called acute angle triangle. One of the angle is 90 degree. So one angle is right angle. That is why it is called right angle triangle. One of the angle is more than 90 degree. So one angle is obtuse angle. It's called obtuse angle triangle. They are the two varieties or splits that we have seen so far. Now I'll give you one magical formula. Two and minus 4 into 90 degree. Okay, that's one formula. I'll tell you what it is for. If I have a triangle, what is the sum of all the angles? This angle, this angle, and this angle.
You would have to the angles.
Yeah, sum of all the angles for any triangle, any triangle. What is the sum of all the angles? This angle plus this angle plus this angle. How much is that? 180? 180. For all the triangles, any type of triangle, be it acute triangle, isosceles triangle, scalene, right angle triangle, sum of all the angles will be 180 degree. Sum of all the angles, meaning the angles inside this one. This. So sum of all the angles will be 180 degree. For any type of triangle, if anybody tells you that there is a triangle, sum of all the angles is 179, don't agree. It cannot be a triangle. Okay. This is the non-negotiable rule. Now if you are looking at, let's say, a rectangle, what is the sum of all angles? 360. Yeah, we'll come to the property of rectangles also, and then you will know 360. Okay. Now I'm telling you, don't have to remember all this. Remember this formula: 2n minus 4 into 90, and replace n with the number of sides that you're talking about. If you're talking about a triangle, put 3 instead of n. So 2 into 3 minus 4 into 90. That is the sum of all the angles. 2 into 3, 6 minus 4, 2 into 90. 180. Quadrilateral or rectangle, square, trapezoid. 4 sides. 2 into 4 minus 4 into 90. How much is that? 2 into 4, 8 minus 4, 4. 4 into 90, 360. Somebody comes to you saying, okay, I have a hexagon. Tell me the sum of all the angles. Okay? Hexagon. 6 angles inside that, right? Hexagon has 6 sides also. Yeah? You will put that in the magical formula. 2 into 6 minus 4 into 90. 12 minus 4, 8 into 90, 720. Any hexagon in the world, total sum of all the angles will be 720. If it is less than that, you can challenge me.